Hello, my young Padawans. I'm glad that you're here. Well, not here, but here on the internet. I need you to work hard. Even though we're not together, you still have a job to do, and that is to increase your knowledge. While we're away, this is going to be challenging, but I need you to work hard just as if you were here. Take good notes as I go through the lesson, and of course, email me if you have any questions. I will always be there to help. I can trust that you're going to do a good job because you are stellar. We don't know how long this is going to last, but you need to work hard for yourself. I know that you will. So, get your things ready. Here we go. Oh, I'm going to wear a hat because we got lights. I balled the glare. You get it. Here we go. Are your notes ready? Here we go. This is lesson 102, growth and decay. The benefit of having a video is that you can pause and go back if you're stuck. So do that anytime that you need. Okay, we're going to talk about maybe a formula, if you will. So growth model, it's when something is growing at, let's say, 5% per year. What you do to calculate that is you take the growth and then add 1. So you're going to multiply by 1.05. So we're going to multiply by 1 plus the growth. This will make more sense in a second, but that's how you calculate growth. Now, if something is decaying over time, you multiply by the remaining portion. So here's an example. If something was decaying by 5%, well, that means it's losing 5%, so how much is remaining? And the answer is 95%. So you multiply by 0.95. So growth model, decay model. All right, example number 1, let's take a look. Ethan has $100 in his bank account, and his balance grows 5% each month. How much will Ethan have in 3 months? Okay, so this is going to be a growth model growing by 5%. So we're going to say 100 times 1.05. You do the multiplication there, and we have $105. Now, every time you multiply by the percentage or the growth is 1 month. So this is how much Ethan has in the bank account after 1 month, but we need to know how much he has after 3 months. So after month 1, he has this amount. So in month 2, you're finding 5% growth on the $105 that he now has. So multiply by 1.05. Okay, now that you see Ethan has $110.25 after month number 2, we need to do 1 additional month. But again, the 5% is growing on his new money. So one more time, $110.25 times 1.05. Calculate this, and then you have how much he has in 3 months. Okay, that's how much money he has after the 3rd month, but you need to make sure that you're going to round this because we're talking about money. So it's going to be $115.76. That's his balance after 3 months. Okay. Davis has $400 in his bank account and the balance grows 6% every year. How much will Davis have in 4 years? Okay, I need you to pause the video and work through this on your own and see if your answer matches mine. Okay, so after 4 years of growth at 6%, Davis will have $504.99. Rich. This is how it happens. After year 1, $424. Take that. After year 2, $449.44. Take that. 6% growth. Now you'll have this. Now, because we're dealing with money, this is how much he has after year 3. Look how much I took over for year 4. $476.41. So I rounded this right there so that I didn't have an uncontrollable amount of decimals to work with. And you can do that same thing. So round here, and you've got your final answer. Again, if you're stuck, go back through, pause the video and take a look at what I've done here and make sure that you practice until you're able to get to the final answer. You guys are doing a great job. Keep it up. Okay, now we're going to look at a decay model. Bennett had $400. He spent a third of his money. So he's going to be losing money because he's spending it, so his money is going to be declining over time. That's called the decay model. That's what we use to find the answer here. How much money does he have after 4 days? Okay, now remember what the decay model was? It's multiply by the remaining portion. So if he's spending a third of his money, he still has 2/3 of his money. Let's take a look at what that becomes. Here we go. So 400 over 1 times 2/3. Again, he spent a third, which means he's still going to have 2/3 of his money. So multiply here, this is equal to 800 thirds. Now, even though we're dealing with money, leave it in fraction form because fractions are easy to work with. So after the first day, he has this much money. So this much money here is about $266 and some change, but we're not going to convert it yet until the very end. Now, this is after the first day, right there. So let's take that amount and multiply it by 2/3, because according to the problem, he spends a third of his money each day. So he'll have 2/3 of that money left over. Let's see what we have here. This is going to be equal to 1,600 over 9. And again, yes, that is going to be some dollar amount, but we don't need to calculate that quite yet. So this is after day 2. Multiply it by 2/3. This is going to be 3,200 over 27. That's how much money he'll have after day 3. And by the way, you may be tempted to reduce some of these things. You're more than welcome to do that if you see something that's going to be easy, but just be careful. So then the final is going to be 3,200 over 27 times 2/3. One more time. This is going to be 6,400 over 81. Okay, let's go back here. So this is how much money Davis still has left over after 1 day of spending of this. Or we're leaving it like this. He spends a third of his money again. Now he has this much money. He spends a third of his money again. And now he has this much money. And then he goes out shopping on that final 4th day, spends a third of his money, and this is how much money he has left over. Now, long divide to see what that amount is going to be. Okay, this is going to equal $79.01. Again, pause the video if I lost you at all. Go back and follow the steps carefully. Okay, this is something called half-life. Perhaps you've heard about this in science. Let's take a look. Carbon-14 is a radioactive isotope occurring in nature. Essentially, all living things, all trees, plants have carbon-14 in their makeup, in their genetic makeup, in their physical makeup. It is used to date materials containing carbon, such as once living plants and animals. Carbon-14 has a half-life of about 5,730 years. If a bone is found containing about 1/4 the amount of carbon-14 as modern day bones, about how old is the bone? Okay, here's the situation. Half-life means over this certain amount of time, half is remaining. So, if carbon-14 has a half-life of 5,730 years, that means in 5,730 years from right now, half of whatever exists in its complete form right now will exist. So here's an example. Let's say that I had 100 pounds of some material, but all the carbon in the material is going to start decaying over time. So in 5,730 years from right now, how much of this is remaining? And the answer is 50 pounds, because half of the substance decayed over the 5,730 year period of time. Now, if we go into the future another 5,730 years, how much of this is remaining? Half of that. That's how half-life works. Okay, so let's take a look at this example here. There are 400 pounds of a certain substance that has a half-life of 9 years. So in other words, in 9 years from right now, half of this substance is going to be left over. How much of the substance remains after 36 years? Okay, let's make a table. This is going to be years, and this is going to be the amount of the substance. Now, it's always important to start at 0 because we want to know how much is right now, how much exists right now. And of course, there are 400 pounds. Okay, now, jump forward 9 years because that's the half-life. So jump forward 9 years. So based on our situation, it says the substance has a half-life of 9 years, meaning in 9 years, half of this is gonna decay. So how much is left over? 200 pounds. How much are you gonna jump here? Up 9 years. So in 18 years, how much is left over? 100 pounds. Jump an additional 9 years. How much left over? 50 pounds. Jump an additional 9 years. How much left over? 45 pounds. So, how much of this substance remains in 36 years? The answer is 45 pounds. Okay, something to recap that we've discussed but we haven't practiced a whole lot is called constant ratio. It's very simple. This pattern here has a constant ratio of 2. Why is that? Well, look at the pattern. Times 2, times 2, times 2, a constant ratio of 2. Now, this has a constant ratio of half. Not divided by 2, but half. So, how much left over? Half, half, half. So, one more example here. If I give you think about the constant ratio here. The answer is 1/3. A third remains, a third remains, and there you go. That's constant ratio. I need you to tackle A through Z from lesson 102. If you don't have a book, I'm going to plot the answers, the questions up here, and you can pause and work through those right now. Awesome job.